Hello and welcome to Chemical Distraction. Alright, so today we are revisiting an old video where we made glacial acetic acid with stuff from Walmart. A lot of you guys had a problem with me using sulfuric acid that I got from Walmart. Yes, my Walmart does sell sulfuric acid, but to offer some sort of alternative, I came up with this method where we use citric acid. Citric acid is a naturally occurring sour acid that is used in things like candies and jams, and you can buy it at your local Walmart. But anyways, to start off, we're going to pour a liter of cleaning vinegar into this beaker, and then we're going to slowly add sodium hydroxide, which we got from this drain cleaner. You can also use baking soda, but the baking soda sort of produces bubbles, which can get a little out of hand. The sodium hydroxide does the same thing, but there's no bubbles. The downside to no bubbles is you actually have to keep track of the pH because you can't just look when the bubbles stop. So we get to a pH of about 8, and let me explain what that does. So basically what's going on here is acetic acid is very hard to separate from water, so if we turn it into a salt, we can easily remove it from water and then turn it back into an acid. So what happens is, when we add the sodium hydroxide to the acetic acid, because the acetic acid is a stronger sort of acid, it wants to get rid of its hydrogen. And it does that by trading its hydrogen for a sodium ion to balance itself out. This leaves us with water and sodium acetate. Obviously there's a bunch of water in this already, so the water doesn't matter. But the sodium acetate has a much higher boiling point now than it did before. With that, we can boil off all the water and we'll be left with just pure sodium acetate. Now, the sodium acetate isn't quite 100% dry, there's still water in it because salts like to hold on to water. So in order to get rid of the water, we cook it in an oven for a few hours, and once it's nice and dry, we grind it up and do a nice little fine powder, and then we put it back in to finish it up, and finally we are left with this pure sodium acetate. So now that we have sodium acetate and we got all the water off, we can go ahead and add the hydrogen back onto it to turn it back into acetic acid. In order to put the hydrogen back on, we need a stronger acid. In previous videos we used sulfuric, but in this case we're going to use citric. So to demonstrate the difference between citric and sulfuric acid, we're going to do a little bit of a taste test. First with citric acid, we're going to give it a little taste. Ooh, it's really sour. It's like a sour candy. Now for the sulfuric. So I set it for distillation, and then I add the sodium acetate to a flask. So then I just sort of pour in the citric acid, I give it a little stir, and then we slowly start to turn up the heat. So now that we mix the two powders, we have the hydrogen on the more powerful citric acid. So the citric acid is going to trade its hydrogen for sodium to make the weaker acid acetic acid. We keep the heat low and we let the reaction sort of go, and as it goes we start to slowly distill off the acetic acid that's formed. Now as the acetic acid starts to boil over, you may notice we've got a code yellow. Okay, everybody calm down, calm down. We can deal with this. I'm pretty sure that the yellow is coming from the citric acid decomposing under the heat. If you heat citric acid up for long enough, it starts to decompose into a mixed match of different chemicals. Some of them probably came over and turned our acetic acid yellow. To maybe sort of remedy this, I take the acetic acid and I do fractional distillation on it to hopefully separate the yellow from everything else. I collect the liquid dripping off from 110 degrees to 125 degrees, and we end up with this. It's not perfect, but it might work. It smells disgusting, which is good. It has a pH of like 2 to 3, which is right where we want it. The only problem is it's a little discolored, and I feel like there's probably a bunch of contaminants in there. But this takes so many hours to do, so I'm just gonna run with it, and we're gonna see if it works. But in future, I will definitely be using the sulfuric acid method. That method is just far better. Yeah. So if you like the video, subscribe. No, seriously, subscribe. Also, check out these cool guys who donated to the lab. If you want your name here, you can donate to the link in the description, or you can buy some merch. And thank you for watching.